In this lecture, we will talk about the inverse sine, cosine, and tangent functions. Probably we will do sine first, and then leave cosine and tangent functions next time. Before we do the inverse of sine, let's review the picture of sine x. You see, this is the picture of y equals sine x. When x is 0, well, y is 0. Okay, so this point is basically 0, 0. And when x is pi over 2 and y is 1, so this point is pi over 2 and then 1. When x reaches pi, and then you will then have this point is pi 0 again. Okay, so it goes like this. From here to here is one period, because here is 2 pi. Okay, and then here is 3 pi over 2 somewhere here. Okay. All right. Now, if you draw a horizontal line, you see that there are more than one intersection with sine x. So this function is not a one-to-one function. If it's not one-to-one, then there is no inverse function exist for y equals sine x. And then what we like to do is we restrict our domain from negative pi over 2 to the positive pi over 2. Okay? And then from negative pi over 2 to the positive pi over 2, that's half a period. Okay, because from negative pi over 2 to the positive pi over 2, that's pi. And then when you draw a horizontal line, you can only have one intersection with the graph of y equals sine x. Okay, so then the function will be one-to-one function. You cannot even move a little bit more to the right, because if you draw this horizontal line, then you have 2 intersections. So it has to be strictly from negative pi over 2 to the positive pi over 2. And from in this domain, then the y reaches from negative 1 to the positive 1. Okay? You can see down here clearly. This picture is banded from negative 1 to the positive 1. Okay, so the range for this one is from negative 1 to positive 1. Okay, and we restrict the domain from negative pi over 2 to the positive pi over 2. Alright, since we restrict our domain from negative pi over 2 to the positive pi over 2, if you look at the unit circle, it basically tells us from a negative angle, negative pi over 2, this point, that will be, if we put the angle down here, that will be negative pi over 2. Okay, and what is the coordinate for this point? That will be negative 0, negative 1. 0, negative 1. Yeah. This point is 0, negative 1. Okay? So, from negative pi over 2 to the positive pi over 2. So when we do inverse for sine, we only consider quadrant 4 angles and quadrant 1 angles. And here is pi over 2, and x coordinate is 0, 1. And then you can see clearly for sine 30 degrees is 1/2, because in a union circle the radius is 1. Here, here, here. Union is 1. And you know if here is 30 degrees, pi over 6 is 30 degrees, then you know this will be 1/2 of this radius. And radius is 1, so this is 1/2. And this is y, so y coordinate is 1/2. Okay? Yeah. So, you know, this is also the things, again, I can remind you, is that, you know, in this ruler, this leg is half of this one, hypotenuse. And here is 30 degrees. Okay. I ask you to keep this in mind. Alright. So then you know sine pi over 6 is 1/2. And those things are the previous things we did. Sine is y coordinate. Y coordinate from smaller 1/2, radical 2 over 2 to the radical 3 over 2 until 1 from 0. And here is negative direction for y. Okay. Now, the inverse function, we can then use a picture to denote it. You know, previously what we did is from the left-hand side angle to find out values of trigonometric functions. Sine pi over 6, 30 degrees is 1/2. And sine 0 is 0. Okay. So far you should be sure. You see, y coordinate here is what? 0 degrees, and here is 1, 0. And y coordinate, sine 0 degrees is 0. That's y coordinate. Okay. So 0 goes to 0. Negative pi over 3 to the radical 3 over 2. You see down here. This is negative pi over 3. That's positive pi over 3. The y coordinate is negative radical 3 over 2. Okay, that's for sine. Alright. So, from angles to the values of trigonometric function sine, blue lines here. Now, for the inverse function is that you want to be able to go back from the image, goes to the pre-image by using the inverse, F inverse. Is also denote sine inverse. Sine inverse is the same thing we say arcsin. Okay, those two are the same. Arcsin means the sine inverse. So here is the place the inverse function is introduced. From values, go back to find out angles. So previously we have sine pi over 6 is 1/2. now it goes back, so you need to write arcsin 1/2, this one, is pi over 6. Now you can also write sine 0 is 0, and then arcsin 0 is also 0. It goes back. And then arcsin negative radical 2 over radical 3 over 2, it goes back. That's negative radical 3, negative pi over 3. So you do is from the this side, the values of trigonometric function, go back to find out the angle. So you can write arcsin. Okay. So basically, if you have a sine negative pi over 3 equals negative radical 3 over 2, then another way to write this is from value, here inside are the values, go back to find out angles. So arcsin something is actually an angle, and sine something is actually a value. Okay, so you want to keep those things in mind. And then y equals arcsin, so y will be the angle. Here goes to this side, and x, the input, are the values. We know x values are ranges from -1 to 1. Okay, so this will be the domain for inverse function of sine. So that's the domain for arcsin. So I wrote here. Okay, and y is the range. Okay, and range, you know, previously we restricted the angle from negative pi over 2 to the positive pi over 2. We got 1-to-1 function. So when we go back from -1 to the +1, we go back, and all those y's must be either in quadrant 4 or in quadrant 1. That's from negative pi over 2 to the positive pi over 2. And all those 2 points, negative pi over 2, positive pi over 2, are included. Those 2 boundary points are included. This also then tells us that x, if you have some x put here is 2, that's wrong. Okay, because x has to be from -1 to 1. So if we put 2 here, that's not defined. Okay, and output has to be from negative pi over 2 to the positive pi over 2. Okay, if you have arcsin equals pi, that's totally wrong. Arcsin, anything cannot be pi. Okay, it has to be inside because pi is out of this range. So that's why we say the range is from negative pi over 2 to the positive pi over 2. All right. Now